Now we'll see the problem number 3. Implement a stack using two queues, Q1 and Q2. So this is the question, and the data given to us are: a stack can be implemented using two queues. It's possible, and let stack to be implemented be yes. Let the stack that needs to be implemented be yes, and queues used to implement be Q1 and Q2. Q1 and Q2. Now, for a queue, Q1, the newly added elements are always put in the front of the queue, and while newly added elements are put in the front of the queue, and while taking, we use the pop operation, which is nothing but dequeuing. So Q2 is used to put every newly added element in front of Q1. So Q2 is used such that every newly added element in front of Q1. Now let's consider two queues, Q1 and Q2. Current number of elements is given as current size. So initially the stack will be having a current size which is equal to 0. Next we do the push operation. In the push operation, the current size is first incremented. The current size is incremented. Then push X first in empty Q2. So next what happens, we are pushing this X, into Q2 first. Q2, that is nothing but Q2 dot NQ of X. This does the function of pushing X first in the empty Q2. Next, pushing all the remaining elements from Q1 to Q2. Then we push all the remaining elements from Q1 to Q2. So while doing this, first we check for a condition, that is, while Q1 dot count is greater than 0, is Q1 dot count is greater than 0. If it is greater than 0, then we put Q2 NQ of Q1 dot peak, and then we do DQ of Q1. Dequeuing of Q1. So next what we do is we swap the names of the two queues. We swap like Q is equal to Q1 and Q1 is equal to Q2, and then Q2 is equal to Q. This is how we swap the two queues. After the swapping of the two queues is done, we go to the pop operation. In pop, if q1.count is equal to 0. If it is equal to 0, then it returns the current value. It returns, and q1 dot dequeuing happens, and the current size is reduced by 1. Then we do the top operation. In top operation, q1, here also the q1 dot count is checked. If q1 dot count is equal to 0, then we return here -1, else we return int of q1 dot peak. So then we see the size function. In this size operation, it always returns the current size. So in the main function, we write the program as, in the main function it becomes for a stack of yes, for a stack of yes, yes dot push of 1 and yes dot push of 2 and yes dot push of 3. Then we go for yes size, S of size, then S of top, and then comes S of pop and S of top, again an S of pop, and S of top, and then S of size. The output for this program will be the current size is equal to 3 then it is 3, 2, 1, and then the current size is equal to 1. This is the received output.